In this video, we're going to go over acid-base titration graphs, which are also known as pH curves, and we're just going to go over what all information we can gather from them. Okay, so first of all, what is a titration graph and how do we get it? Okay, so right here is a titration graph, and how we are able to get it is by setting up a titration. So what does a titration setup look like? It looks like this. So here we have a burette, which is kind of like a long stick that holds a liquid called our titrant, and our titrant is a solution which we very accurately know what the concentration of that is. Now down below here, so this kind of conical shaped flask, that's called an Erlenmeyer flask, and it's going to hold our analyte, which is a solution that we do not know what the concentration of it is. And usually what we do is we're going to put an indicator in with the analyte so that it changes color at a certain pH so that we can accurately measure where the equivalence point is. And the equivalence point is the volume of titrant that tells you how much you need for a stoichiometric reaction. So that's a little bit new information for what we've learned so far in this course, but that's the whole point of a titration, is so that you can tell how much titrant you need for a stoichiometric reaction, which is when you have the amount of reactants needed for the reaction to go forward as predicted by your balanced chemical equation. Okay, so if you wanted to see this in real life, what that would look like this. Okay, so here we have our burette, and the titrant is already in the burette. Here is the Erlenmeyer flask, which already has the analyte in it with an indicator. So typically when you're doing a titration, the burette is an instrument that very accurately measures how much titrant you've used, and while your titration is going, which he has it kind of slowly dripping into the Erlenmeyer flask, as your reaction happens, the indicator will slowly turn color. So right now he's just going to, I guess he doesn't have the burette open just yet, but he is adding indicator in right now. And let's speed this up a little. So what he's going to do is he's going to open up the stopcock on the burette and slowly add in titrant until his indicator turns color. So the reason why he's going so slow or adding the titrant so slowly is just so that he gets an accurate measurement. Now, when he gets close to the end point, which is going to relate to the pH of the solution. So when he gets close to the end point of his titration, eventually the color of the indicator, it's going to stick around a little bit more. Okay, and the goal for titration will be so that the color change of your indicator is light, but it stays. Okay, because oftentimes what you'll do in a titration is you'll put in a drop of titrant, you'll have your indicator show up as this pink color, but when you swirl it, it's going to disappear. But as you get closer and closer to the endpoint, which I'll explain all what that means on the titration graph in a second in our notes, but the color of the indicator starts to stick around a bit more when you get closer to the endpoint. So there it disappears once he stirs it. And now he's going to add a bit more. But again, he's going very slowly. So now we have this faint pink color, which is sticking around, and that indicates that he has reached the end point of his titration. So what exactly is an endpoint? What is an equivalence point? We will be going over that on this graph, because this is things that you can determine on a titration graph, which is also known as a pH curve. Okay. So a titration curve does give us important information about the kind of acid and base used in a reaction. A pH curve is a graph that shows the continuous range or the continuous change in pH during an acid-base reaction. So we can determine, first of all, we can determine if the sample is acidic or basic and whether the titrant is acidic or basic. So as a reminder here, the sample, that is what's in the Erlenmeyer flask that is below. So if we look at our screen grab, actually I'm going to go back to the video here. So the sample is what is in this Erlenmeyer flask, and that's what we don't know the concentration of. In our other diagram, we called it the analyte or sample, same thing. Okay, so let's just do a little diagram here. So if I draw an Erlenmeyer flask, and then the end of the burette, so the Erlenmeyer flask, that has our sample in it, as well as the indicator. Oop. So this is the Erlenmeyer flask. Okay, sample and indicator. Whereas over here, the glass instrument that's used, that's the burette. And it contains, or it holds, the titrant, which is what you know the concentration of. Okay. Now, how we get all of these data points on the pH curve is usually through a pH meter, which you didn't see in the video here, but that's okay. We can draw it in. So the pH meter is just like a stick with a wire attached to it. And that is going to measure pH of the solution or of the sample. So if you wanted to see what this looks like in real life, then this would be what it looks like. So in this case, the blue stick thing, that is the pH meter. So it's continuously measuring the pH on this little, let me do a screen grab here. Oop. So this is the pH meter stick. That's the thing that's going to be measuring the sample, and where it's going to show you your values for pH is on the screen off to the side here. Okay, so it tells us what our sample is, whether it's acidic or basic, and it also tells us whether the titrant is acidic or basic. So since the pH meter at the very start of the titration, the pH meter is only going to measure the pH of the sample, because that's all you have in there at the very beginning. You have not added any titrant in just yet. So if we go to our pH curve here, at the very beginning, this is going to be the pH of the sample. So we can see that the sample has a pH of 11, so we can say it is a fairly strong base. Okay. Now, as we progress through the titration, the pH of the sample, as we add more titrant, the pH of the sample solution gets closer and closer to the pH of the titrant. So at the very end, this is where we're going to be able to tell what the pH of the titrant is. So pH at the end of the titration is closer to the pH of the titrant. So from here, since the pH at the very end is right around 3, we can figure out that the titrant is a pretty strong acid. Okay. So another thing that we can figure out from our titration curve is going to be the equivalence point volume. So where the equivalence point volume is, right here, like it's already got it pointed out, but if you had to find it manually, what you would do is you would kind of eyeball where the steepest part of the graph is. So I'm going to say like the steepest part of the graph is between these two purple lines I just drew, and then the equivalence point is always going to be smack in the middle of the steepest part of the graph there. Okay, so I just draw these lines just to help me eyeball the middle of the steepest part of the graph so I can figure out where my equivalence point is. Okay, so the equivalence point, once we figure it out, we're just going to trace our finger down to the x-axis, which tells us how much volume of titrant that we added. Okay, so this right here is telling us the equivalence point volume. And it's going to be in milliliters. So this tells you how much titrant you added. And it tells you how much titrant was added to achieve a stoichiometric reaction. So a stoichiometric reaction is just when your reaction proceeds just as your balanced chemical reaction predicts that it will, and 100% of products are produced. So the volume at the end point is referred to as the equivalence point of the titration. Okay, so now we need to show where we're going to find our endpoint, because endpoint and equivalence point, you can find them kind of in the same spot, but equivalence point refers to volume, endpoint refers to pH. So I'm going to take the same spot and trace my finger over to the y-axis this time. Okay, and this is going to be our endpoint. So endpoint, which is your pH. So it tells you the pH value that the endpoint happened at. So with this and with pH curves or doing titrations, you can't just throw in any indicator into your sample. You have to choose an indicator that has the endpoint pH in the middle of the range of the indicator. So again, you need to choose an indicator with the endpoint, which refers to pH, in the middle of the range for the indicator. Okay, another thing that I'm going to add in here is, I said it, I just didn't write it down. The equivalence point is at the middle of the steepest part. Of the graph. So we've already gone over endpoint. So the endpoint happens in the region of fast change in pH. So in other words, the steepest part of the graph. Okay. And it shows that the buffer is used up. So what a buffer is a substance that resists changes to pH. So let's write that over here. Okay, and we can actually tell where the buffer zone or the buffer area is. So the buffer area, it's always going to occur usually in the first plateau if you just have like a monoprotic acid or base that you are titrating. But if you have a diprotic base or acid that you're titrating, it's going to be the first two plateaus. But the main point is your buffer area is never going to be the last plateau. Okay, that's maybe a better way to describe where to find buffer areas. It's never the last plateau. Okay, so for here, because there's only one plateau, and maybe I'll make this a bit bigger. So this right here is the buffer area. How we can tell is because the pH is not changing very much. And the whole point of a buffer is to resist changes in pH. So that's how you can tell. Okay. However, as the titration occurs, the buffer gets used up. And so at this point, there's no more buffer. That's why this last plateau cannot be a buffer area. Okay, we've already marked out the endpoint and equivalence point on the graph above, so I'm just going to keep on going here. Okay, we can also determine the appropriate indicator to use in the reaction. As I said above, how you choose your indicator is you got to make sure that the endpoint, which correlates to pH, is going to be in the middle of the range of the indicator. Okay. So when given a pH curve, it's easy to determine an appropriate indicator for the reaction. Choose an indicator that closely matches the endpoint of the curve. Remember that the best indicator to use for a titration is one that has the range that includes the equivalence point of the titration. The closer the equivalence point is to the middle of the range for that indicator, the better. Okay, so for here, since the endpoint occurs at a pH of 7, let's just see if we can find an indicator that would work for this. Okay, so let's see. We could use bromothymol blue because a pH of 7 is right in the middle of it. We could also use phenol red as our indicator because once again, 7, our endpoint, is right in the middle of it. Okay, and that looks like the only two possible indicators we could use. I would say out of the two of these, phenol red is the better of the two indicators to use just because our endpoint of 7 is closer to the middle of this pH range for this indicator. The other thing that we can figure out from pH curves is the type of reaction taking place. So typically in Chemistry 20, we're only going to deal with reactions between strong acids and strong bases. However, in Chem 30, you start talking about reactions between strong acids and weak bases, or strong bases and weak acids, so on and so forth. Okay. So on the axes provided, sketch the titration curves for the indicated neutralization. So remember, a neutralization reaction is just a reaction that occurs between an acid and a base, and what is produced is water and some sort of salt. Okay, assume concentrations of acids and bases are going to be the same. All right, so let's take a look at this. Example A, we have a strong acid. So that means we have a low pH. And it's titrated with. Okay, so titrated with, keyword, because that tells you that whatever comes after it is going to be your titrant. Okay, so our strong acid is titrated with a strong base. So our strong base is our titrant, and our strong acid is going to be our sample. So reminder that for a pH curve, you start out with your sample pH, and then you get closer and closer to your titrant pH. Okay, so strong base has a high pH. So essentially what we're doing is we're going to go from a low pH to a high pH. Okay. So essentially what that's going to look like is like so, and I've tried to line it up so that my endpoint happens right at a pH of 7 there. So the reason why I wanted it to end up, or the steepest part to end up at a pH of 7, because that's where my endpoint would be. So maybe I'll get rid of that. Just draw a dotted line. So endpoint. The reason why I wanted that to end up the way it did is because when you have a strong acid reacting with a strong base and the concentrations of both of those are the same, it's going to completely neutralize your solution. Okay, so that means your end product will have a pH of 7. So this is pH of sample. Okay. And then this isn't going to necessarily exactly be the pH of the titrant, but closer. We'll say closer to pH of titrant. All right, so over in this box, we're just going to just write a few notes here. So endpoint is at a pH equal to 7. And for our indicator that we could use, like I said, we could either use bromothymol blue or phenol red. Either would be good, so I'm just going to talk about what we could expect from either indicator. So let's go back here. So let's first talk about bromothymol blue, just because. Alright, so the color change we would expect. So first off, we're going to talk about what we would expect at the start and what we would expect at the end point, because those are the two we care about. We don't really care about what the color would be at the end. All right. And you know what? I'm just going to write out what would happen for phenol red as well. And we can do this all in the same go. Alrighty, so to start off, so the pH of the sample is pretty low, okay? So let's just say because it's a strong acid, let's just assume it has a pH of 2. Okay, I'm just pulling that number out of the air. All we can know for certain is that it has a low pH, and I'm just giving us a specific number so that it can help us answer these questions. Okay, so for bromothymol blue at a very low pH, okay, it is going to be like at a pH of less than 6, so then it would be yellow. So then let's write that out. But our endpoint, that's at a pH of 7. So let's check out what that would be. So at 7, it's going to be in the in-between range. So it's going to be the in-between color between yellow and blue, which is going to be green. Now let's do the same for phenol red. So again, we're starting off with a low pH. We'll say 2, just to have a number to focus on. So for phenol red, a low pH is going to be below 6.6. So it is also going to be yellow to start off with. And then for our endpoint, which is occurring at 7, the color of it is going to be in between 6.6 and 8. So now we're going to deal with the in-between color between yellow and red, which is going to be orange. And there you have it. Okay. Let's do the same thing with example B here. We have a strong base, so that is our sample, and it has a high pH because it's basic, is titrated with, so this is going to tell us our titrant, which is a strong acid. So acids, they have a low pH. So essentially we're going from high to low here. And once again, I'm going to try and make sure that the steepest part of my graph lines up so that my endpoint is at 7. There you go. So this is my sample pH, starting off high, and then right here will be a pH that's closer to the pH of my titrant, which is a strong acid, so it's going to have a low pH. So again, any reaction between a strong acid and a strong base will have an endpoint at a pH of 7. So 7, 7.0, both mean the same thing. And because the endpoint is at 7, we can use the same indicators that we used in our previous example here. So bromothymol blue and phenol red. Actually, I'm going to move that up a little bit so that I have enough space. So start, endpoint, And then same deal with phenol red. Okay, so what we can assume is that our pH, since our sample was a high pH or it was a strong base, okay, so let's just pick a high pH. So let's say 13, just so that we have a number to focus on. I am pulling that number out of thin air here. Okay, so for bromothymol blue, if our sample started off with a high pH, so we're saying, for example, 13, that would be at 7.6 and above, or it would be above 7.6. So then the color of it would be blue. Okay, and for our endpoint, which is at 7, once again, it'd be the in-between color, so it would be green. So let's write that down. So we're starting off blue, and we're going green. Same deal for phenol red. Let's take a look at it. So starting at a high pH, so we'll say 13, but moral of the story is it's above 8. So that means that our indicator will be red. And then since our endpoint is at 7, which is the in-between, or a number in or within the range, then we're at the in-between color, which is orange. So we're starting off red, we're going orange. And there you have it. Okay. So down below here is just some more examples of graphs. Okay. And so if we look at this here, at the start, that's going to be the pH of your sample. So we can figure out that our sample is a strong acid. Okay, and our titrant is a strong base. Because again, in Chem 20, you only deal with strong acid and strong base reactions. Okay, that's not to say that your sample will always be a strong acid. It could be a strong base, and your titrant could be a strong acid. But, you know, your sample will either be a strong acid or a strong base. Your titrant will either be a strong acid or a strong base. Okay, our equivalence point still happens at our endpoint still happens at a pH of 7, and our equivalence point, if we trace our finger down, happens at 50 milliliters. So equivalence point volume is equal to 50 milliliters. Okay, so that's how much titrant we had to add in order to get to a stoichiometric reaction. Okay, and let's also just label the endpoint here. Endpoint is equal to a pH of 7. Okay, with this one here, our sample is a strong base, because you always look at where your graph is starting to tell you your pH of your sample. And since it ends up being a low pH, that means your titrant is a strong base, or sorry, a strong acid. Okay, and again, we're going to eyeball, since it doesn't have this labeled out, so the steepest part is right there, so about the middle of that is right there. Drawing as straight a line as I can. So our endpoint is at a pH equal to 7. And our equivalence point volume, I'm just going to get rid of these lines because the whole point of those lines I just erased was to help me eyeball the endpoint. So now if I trace my finger down, that wasn't a very straight line. Yeah. So my equivalence point volume looks like it's happening at about 24 milliliters. Okay, moving on to example 1 here. So we have 25 milliliters of acetic acid is titrated with, so titrated with, that tells you this is our titrant. So it's titrated with a 0.040 mole per liter solution of barium hydroxide. Use the information in the graph to answer the following. Okay, so we're asked to label the endpoint and equivalence point on the graph. All right, so we're looking at the steepest part. So again, I'm just going to draw the lines here just to help me kind of eyeball where the steepest part is. So right in the middle, so right about there. So drawing as straight a line as I can. That wasn't very straight. So our endpoint happens roughly at a pH of 10. And the equivalence point volume. Okay, so for this, just got to trace down, and ideally this would be better if I had a ruler here. But what I'll use instead is just a line tool, because that's what I have access to. Okay. So, looking like our equivalence point volume is right around, so each of these tick marks is worth 2, so right around 34 milliliters. Okay. Okay, if you wanted to be super specific, just because it's just below 34 milliliters, you could say or 33.9 or 0.8. We'll go with milliliters. Okay, but with this scale here, you're ultimately estimating the last digit if you are going this route. Okay. So just a reminder here, endpoint is all about, okay, what is the pH? Okay. Equivalence point is telling you how much volume of titrant that you added. Next, we're asked to label the buffering area. So remember, it's never going to be the last plateau. So the only other plateau is right here. So right here where it's resisting change to pH, that is going to be your buffering area. That right there, that's not part of your buffering area because like the pH is actually changing quite a bit there. Okay, so right there is your buffering area or buffer area, same thing. And just as a reminder here, the buffering area is where the solution is trying to resist changes to its pH. So that's why I'm always kind of putting a square around the area where pH doesn't change a whole lot. Okay, but then at this point, that's when like the buffer within the solution gets used up, and as a result, the pH of the solution changes by quite a bit in a short amount or a small amount of titrant. Okay, the buffering area is never the last plateau. That's the best way I can describe how to figure out where the buffering area is. Okay, and then last but not least, determine what indicator would be appropriate to determine the endpoint for this titration and what color change would occur for that indicator. All right, so our endpoint pH is at 10, so let's figure out what indicator. So by the way, if you were wondering, wait a second, I thought that the teacher would say, or that the teacher said that our endpoint pH is always going to be 7 because in Chem 20, our titrations always happen between a strong acid and a strong base. That's true. However, in this example that we are given, we're actually given a weak acid reacting with a strong base, so it's a little bit more of an interesting example, but it's not going to change the fact that in order to choose an indicator, we got to figure out what indicator is going to work best with an endpoint pH of 10. So we got to figure out, okay, which indicator has 10 right in the middle of its range. So if we take a look here, let's get rid of that. So looks like we could use thymolphthalein because 10 is in the middle of it. And we can't use alizarin yellow R because 10 is not in the middle of its range. It's just outside of it. So we're also not going to use phenolphthalein, which is this one right here, because once again, 10 is at the end of the range. It's not in the middle. So our only choice is thymolphthalein. Okay, so its ranges from 9.4 to 10.6. So let's just write that down. So, endpoint pH is equal to 10. Indicator we chose is thymolphthalein, which has a range from 9.4 to 10.6. So our color change, so again, we're going to do what we're starting off with and what the color would be at the end point. Okay, so keep in mind, looks like we're starting off with a pH like kind of 4.5, 5-ish area. So what color is thymolphthalein at a pH of 5 is my question here. So 5 is obviously below 9.4, so it's going to start out colorless, and the endpoint is in between 9.4 and 10.6, so we're dealing with the in-between color, which would just be light blue, because that's in between colorless and blue. So let's write that out. So we're starting off colorless. And then we go to light blue. So if you're wondering what that looks like there, like I can't give you an exact replica of this situation. However, I can tell you what it looks like when one uses phenolphthalein, which is colorless to pink. So it still kind of gives you that idea of what it looks like to go from colorless to pink, and what the end point color would be that you'd look for. So that goes back to this video here. So starting out here, maybe we can see a little bit here. Starting out here, we can see that, if I can get rid of this, at the endpoint, it's going to be this light pink color. So a very faint pink color that is the color of the endpoint. So similarly with thymolphthalein, it would just be light blue, just for what you would look like or look for your endpoint color. Now what he ends up doing is he continues to titrate this solution to get like an even stronger pink color. Okay, so since it's no longer this faint pink color, he's overshot the titration on purpose, just to kind of show you that the color that you do get is pink. And if he continued further, then he would get this sort of super hot pink color if he added in more of his titrant. Again, just a reminder that the indicator that he's using in this experiment is phenolphthalein, which has a color change from colorless to pink, whereas thymolphthalein, which is what we were talking about in our example here, that has a color change from colorless to blue, but the endpoint color you'd be looking for would be a light blue color. Okay, the whole purpose of showing you that video again is just to show you like kind of what the light blue or the light pink endpoint color would look like, and just use that as an analogy to show you what the light blue color would kind of look like if you imagined it was light blue instead of light pink. All right, example number 2, we have 10 milliliters of sodium hydrogen carbonate. So that is going to be our sample. Oop. Is titrated with, so that means this is going to be our titrant, hydrochloric acid. So it says use the information in the graph to answer the following. Label the endpoint / equivalence point on the graph, the endpoint pH. Okay, so with this, I'm going to draw my lines to help me figure out the steepest part and just kind of eyeball the steepest part here. So using my line tool, I think that's as close as I'm going to get. Since each tick mark is worth 0.2, then this looks like that this could be about 8.3-ish. Okay, so let's write that down. So endpoint pH is about 8.3, and the equivalence point volume, so I'm just going to use my line tool again. So looks like each tick mark is worth about 2, and it's slightly above the line for 38, so we'll say 38.2. Again, I'm just estimating this last digit here. Okay, keep in mind for reading graphs, there is a little bit of wiggle room for your answers here. So if you got a pH of 8 for the endpoint, that would be fine. Okay. By the way, this little squiggly line just means approximately. And same with the volume, or 38 milliliters is fine too. Okay, next we got to label the buffering area. So a reminder, buffering area is never the last plateau. So then we can say this area here, that is the buffering area, because the solution is resisting changes to pH. And then determine what indicator would be appropriate to determine the endpoint for this titration and what the color change would be. Okay, so endpoint pH, it's like around 8, 8.3, somewhere around there. So let's look at what we could use. Okay, so with our indicator here, looks like we could be using phenolphthalein, but it's not ideal since 8.3 is pretty close to the edge of the range for this indicator here. So let's try and figure out a better one here. Okay. So a better one would be Cresol red, because like an endpoint pH of like 8, 8.3, that's definitely in the middle of this range. So we could use Cresol red, or we could use Thymol blue if we're saying that our endpoint pH is 8.3. I'm gonna stick with Cresol red though, just to have just like one indicator to use there. Okay, so again, 8, if you did say 8 for your answer, that's fine, but you need to adjust your answer for like what indicator you would use. I am going with the endpoint pH of 8.3, so Cresol red would be the best indicator to use based off of my information. So Cresol red. So the range that I'm most interested in, it had a couple of ranges, but the one I'm most interested in is from 7 to 8.8. And the color change, again, the start of the curve to the end point. So if we take a look at it, so going back, I should actually look at my titration curve. Okay, so starting out, we have a pretty high pH. We'll say it's about 12.2-ish. Okay, so the color of Cresol red at 12.2 would be above 8.8, so it'd be red. So we're starting off with red. And then the endpoint, which I'm going with 8.3 for my endpoint. The color of it would be in between 7.0 and 8.8. So the color is in between yellow and red. So it's orange. And there you have it.